Okay, so this next example is actually example 4. Sorry about that. In this example, we're going to talk about something called the third angles theorem. And basically all it says is that if I know two angles of a triangle are congruent to each other, like A and D and B and E, I can conclude that the third angles are congruent, that C and F are congruent. Because if these angles are, let's say, 180, or not 180, that's impossible, 150, that this third angle has to be 30. That means this is 150 and this third angle has to be 30. So if we know two angles are congruent, we can assume that third angle is congruent. So in this diagram here, we look at using this third angles theorem. We're finding the measure of DCN, which is this one right here, DCN, okay? Well, we can conclude here, all right, we can conclude that D is 68, right? These angles are vertical, so we know those are congruent. So we can assume, we don't know that these triangles are congruent necessarily, but we can assume that the measure of angle DCN, or I'll say that just that they're congruent, angle DCN is congruent to angle SRN. So that makes the measure of DCN 75 degrees, okay? And now you might think, yeah, that makes sense, but the reason we can say that is because D and S are marked congruent, and these two angles are congruent because of vertical angles. That's the only way we can say that, all right? So we have to be able to make sure that those triangles, we can say that those are congruent, that those angles are congruent. Now, I didn't say that the triangles were congruent yet, and we said for triangles to be congruent, all of the corresponding angles have to be congruent, and all of the corresponding sides have to be congruent. So in order for me to say that these two triangles are congruent, I really have to go and think, you know, what other things need to be proven congruent. We already proved all three angles are congruent to each other. That's fine. We know that CN and R, or RN, CN and RN are the same, so that's good. But the last things we have to prove that DC, or we have to say DC has to be congruent to SR, that's not marked, and then that DN is congruent to SN, because those aren't marked as congruent. So it's knowing all three pairs of corresponding angles, all three pairs of corresponding sides have to be congruent for the shapes to be congruent, okay? Just because all three angles are the same measure doesn't mean the triangles are necessarily congruent. We have to be able to say all three pairs of angles, all three pairs of sides. So that's a lot of information that we have to know to assume that triangles are congruent. For a quadrilateral, four-sided shape, it's got to be all four pairs of sides, all four pairs of angles to be considered congruent. So this guided practice goes back to everything from all of these notes and has you kind of use them to solve some problems. So this is a good chance for you to get some practice. I know we're virtual. This is a chance for you to get some pencil to paper practice before you move on to another quizzes, because those quizzes, I'm posting those because I think that's an easier way for you to share your work. I know not everybody has the internet capability of taking a picture of their homework. So if you like the paper and pencil practice, you're free to do them. If you want that counted as your practice, do that and send me a picture. I'm fine with that. But I am requiring the quizzes because I feel like that has more access to more people to get done, okay? So take a minute, pause the video, work out these 3 problems, and then check your answers with me when you are ready. Okay, so for the guided practice, identifying all of the pairs of congruent corresponding parts kind of seems like a lot of work for not a lot of reward, but I want you to understand all 4 pairs of angles, all 4 pairs of sides. So all I did was I looked more at the congruent statement. A and C, B and D, G and E, H and F. That's how I match those up. Angles I think are easier to match up. AB, first 2 letters. CD, first 2 letters. BG, second and third. DE, second and third. GH, last 2. EF, last 2. That's how I match up those. And then the tough one, AH and CF, the first and last, first and last. Because if you look at the diagram, AH and CF are definitely segments. Those segments are congruent. So that's how I name them all. Now, knowing that helps me solve these equations, because if I look at my naming, find the value of x, well, 4x plus 5 represents angle H, and from our diagram, we know H is congruent to F. So 4x plus 5 is equal to 105. I go through and I solve that. I got 25 was the value of x. So that's an important thing. Okay? And then finally, the last one, I know my marker got a little skinnier. Hopefully that helps my handwriting a little bit. But BDC, really, this is kind of like that third angles theorem. But if we look at it, we know that A and B are both 45. We know that these two angles at the bottom are both 30. So if I look at this triangle as its own triangle, BDC is this angle, which is 180 minus 40 minus, or 45 minus 30, which is 105. So this is an important one, number 3, because it's two overlapping triangles. So you've got to use a little bit of critical thinking to find that third angle in the triangle. This is a very important problem. So just keep that in mind for future lessons that we're going to cover in this unit. So now you're ready for the kind of the second half of the practice to kind of round this out. It's going to be another short one. Hopefully you go through it and it makes sense, and then you can move on to the checkpoint.